Hello, welcome to today's data structures video. I want to talk about another topic that is vexing to a lot of people as well as to architects as well, is how to deal with a reporting hierarchy. It seems like a simple structure, but at the end of the day, it is a bit more complex. And how you decide to deal with it depends upon how flexible you want to be, how complex you want to be, and exactly what your overall requirements are. So when we talk about a reporting hierarchy, what is it that we're talking about? Well, let's take a look at one right here. And it is simply, this one is a sales reporting hierarchy to where we have sales offices in cities, and those cities roll up into a state. And those states are grouped into areas. For example, Northeast, Mid-Atlantic, and the Southeast have these examples of states and the city's offices within those. And then we actually divide the entire United States up into regions. North, South, East, and West was the assumption that we'd be doing here. And this is just a piece of the hierarchy. So when you have this type of hierarchy, where does it come from and what do you do with it? Well, typically what it's there for is to provide you a roll-up reporting structure. How many sales were done in the east of the United States? How many sales were done in the state of Connecticut, etc. And you would roll this data up and do reporting through a dashboard. These hierarchies usually come from the team that is doing the reporting. And historically, they've put them into spreadsheets and figure out how to get the reporting spreadsheets into their data or their data into their spreadsheets, one or the other. This type of data typically is not maintained in your transactional system because it serves no transactional purpose. But if you're being asked to do reporting for one of these teams, they will give you their hierarchy and say, please report our data according to this hierarchy. So in this video, we'll talk about multiple methods that you can utilize to store this data in your reporting database so that you can use it for effective reporting. We'll talk about some of the pros and cons of each of the structures, as well as look a little bit at what maintenance you have to do to them and how that impacts it. I also like to highlight that this is not to be confused with the network or transactional hierarchies that are discussed in earlier Alteryx videos, to where that is actually your transactional data or network data, such as the relationship between computers or the relationship between events. This is simply a much simpler structure that is there for reporting purposes. So again, we want briefly talked about these are not network or transactional hierarchies. Those are a bit more straightforward as well as a bit more confusing or difficult to utilize. And if you're trying to deal with a network or transactional hierarchy, see my other videos in the series so that it talks about how Alteryx can build those and navigate those, because the hardest thing about a hierarchy is navigating it. We'll talk about ways to do this, to store the data in a relational structure, the reporting structure that you might be using, and then finally talk about how big of a deal or how complex this makes it within your data and dimensional Kimball type data structures. So obviously, let's jump into the data modeling of this data. So simply going to do some dragging and dropping, in this case using my SQL database modeler system. Is actually just dropping them in. So if we take a look at the hierarchy that we have from a relational standpoint, there are two ways that you can store this. I'm not a big fan of either way of storing these in a relational system, but you can choose which one you would want to do. So if we take a look, for example, we have the sales region, and we'll drop that in here. Your sales region starts at the beginning of it from a basically transactional system. You'd give it an ID and a name. That's all that exists within it. You may have an address. I don't know. There's maybe some other information you put in there as well, but at the basic point, you have an ID associated with the name of it. If you want to keep your relational structure more simple, you would then begin to create additional tables for each of the steps in your hierarchy. in which case we would create a sales area that has an ID. It has a relationship to a sales region, and this area has a name as well. So all the sales regions that have this, all the sales areas that are within a sales region would be put within these two structures. Continuing down the hierarchy, we would then add in the sales state. Same type of data, information that you're going with. And then finally, you would add your sales office. This is a highly relational system. It fits the rules of normalization. The primary key, it directly identifies it because each sales office is unique. It has a sales state associated with it. And the sales states, again, are unique. And they have a sales area associated with them. And we move upwards from there. You have to be careful because some of the data would still be normalized but might violate the overall definition of a hierarchy. So you have to make sure that your data coming in is clean, because a clean hierarchy is what you want. You could store one that is not quite so clean. If you want to store a clean hierarchy, then you would go with a more extensive relational structure, one that I typically would not build either of these. So if we look at sales region 2, it looks a lot like sales region 1, but in this case, we're actually going to give it the name of sales region ID because we're going into a bit more normalized structure rather than an OLTP kind of structure, and it makes some of our relationships coming down. So we add sales area 2 to this picture. And you see that what we do is we have sales region 2 not only have the sales region, but it's part of the primary key. Because now what we want to do is to completely use the database to control the relational constraints. And so the sales area is defined as both of these. As well as you can now come into your data structure within the sales area and know what the sales region is without having, well, actually this is the case over here too. Let's get the third one that actually shows this point as well, sales state 2. There we go. So where sales state comes in is that now we have all of the parent keys being passed down to it. So we have the sales region as a primary key, we have the sales area as a primary key, and so we have a 3 attribute composite one. So we have all the information we need right here to do some work with. And then we finally drop in the sales office at the very bottom. And you can see that it has all of the identifying keys as part of the primary key so that you can realistically jump into any level that you want and do your roll-ups directly from this. This sort of violates some of the relational structure, the third normal form dimensional rules of relational databases. But again, a lot of people like to implement it this way. It's a lot harder to maintain this way. There's a lot more information floating around. And I typically do not use this kind of structure either. So here's something you won't hear me say a whole lot. What structure would I typically implement? Well, let's go ahead and remove all of these and talk about the structures that I typically would go ahead and build, because again, you're looking at a reporting structure. So let's go ahead and drag a few other tables into it and look at the one that is typically implemented, and there is absolutely no reason not to implement it this way. And it is the sales hierarchy report. It is simply a table, and it has all 4 attributes. It's given an ID. It looks a lot like a dimension, but it really violates rules of dimensionality to a degree. But this is what we built. So it has sales region, sales area, state, and the office all within the name, and it's given an ID. Very simple to build, comes right out of our source data that's given to us as a spreadsheet, and we simply store with an ID and attach that ID where it needs to be attached, typically by going in through the sales office and finding that as unique and adding the ID going forward. From a maintenance standpoint, what you would typically do in maintenance is they would redesign their structure typically on a yearly basis, and then you would simply have to rebuild all of your data and rebuild the reporting sales hierarchy table as well, reattach it where it needs to be attached, and go on from there. If the sales office name does not change, then you simply don't only have to modify the data and not any relationships that this table would have to other facts that are going on. Another way that this could be implemented that's a bit more relational, and again, it's not necessarily one that I do. So let's look at sales hierarchy report 3. We bring it in and you can see it has a bunch of foreign keys over here because what we've done is we've gone ahead and attempted to normalize this data a little bit more into relational structure, and we would have a sales region 3 structure. That is simply the ID and the name. So we would create a separate table for each of the levels of the hierarchy and attach them to the reporting hierarchy table because it has the foreign keys for each of these tables. This becomes a bit recursive to do. Here we go, there's state, and then finally we need office. There's office 3. And drop it in as well. So you can see that we would maintain each of these values independently and then simply as relationship drop them into our hierarchy within each of those attributes. This gives you a little bit of control over if you have to rename something over here. It's pretty easy just simply to rename the sourced or parent table, and then because of the key it would then be able to inherit that within your reporting. Again, since we're just still in reporting structure, that's changed very infrequently and it's coming from a managed source. I typically would not build this. It seems to be a little bit of overdoing it all. But people do indeed build this structure because they are comfortable with it and they feel that it is a bit more of a relational structure because it looks like a relational structure, but actually in the maintaining the data, it really is not as relational as a lot of people tend to think that it is. So let's go ahead and take these off and talk about what to do in the dimensional world, because it does present a problem. Because if you look at the initial implementation of Kimball, he didn't have a way of dealing with hierarchies either, and he had to add them later. But again, since what we're looking at is strictly reporting, I find no problem whatsoever with creating a dimension that is simply your sales hierarchy. Interestingly enough, this looks a whole lot like the reporting table that we had out there as well, just that we changed the ID to a WID. And it is. There's no reason not to build this data. You have to go through some trouble in operation to figure out how to attach this information to your reporting records and your fact tables, but you can do it and go on with life and reporting with having this as simply a dimension into any of your facts. It is not flexible enough to go ahead and begin to maintain this data. But again, since this data is low maintenance, it's typically simply a replacement kind of process. You can go ahead and rationalize and talk about how you would like to do this. Well, Kimball didn't like this because this really sort of violates what a dimension table is all about, because it really has relationships within the data as opposed to strictly a piece of data that describes a single entity. So what he came up with for this and for other problems is something called a bridge table. So what we would start with is an element table of the sales hierarchy. So what we have is we have the elements. They're given an ID, the name text, and then their level name. So for example, you would have a record in here for each of the regions, a record in here for each of the areas, a record in here for each of the states, and a record in here for each of the offices. They would exist as simple data elements, and it was actually a fairly good and accurate dimension, except for the fact that it sort of violates the rules of what is the entity that you're talking about. But since we've talked about it as a hierarchy element, we can then utilize and feel confident that we've done some nice dimensional relational structure that is simply the element. But what we want to do is also have this whole hierarchy that we want to attach simply to a fact table. Because if we attach this to a fact table, this is where it falls in the fact table, but it doesn't actually represent that hierarchy and give us the reporting of it. And so what we would need to do is to relate these elements into the hierarchies. And since it's to a degree a many-to-many relationship, the fact that the season, the region would exist in many of the hierarchies, and the many hierarchies would have an individual region, Kimball came up with the idea of a bridge table. A bridge table is how you rationalize within the dimensional structure the whole many-to-many relationship, rather than being a cross-reference table, which is what would be in a OLTP type system. He came up with the term of a bridge. And if we find bridge over here, we drop bridge into it. So the bridge table simply relates each of the elements into the overall hierarchy. It doesn't really maintain order, but since we have the level name, we know what the ordering looks like, so that if we want to find all of the sales for a specific state, we would simply look in the bridge table for the state elements by joining from here to here and then going into the fact table, because this is where we would drop off our fact. A simple dimension that is the hierarchy would then become a dimension into that fact table, and we go on from there. In some cases, this gives you more flexibility in reporting that you might need to have, but again, it might be more complex than you need it to do, and this type of dimension here can be easily implemented and used. Now, if we want to talk just a little bit about where the future would go with this, is that we have this is considered a simple hierarchy. Your hierarchies can get more complex. And then you would need to go into some of the more complex structures when you deal with these more complex type of hierarchies. And the typically one we talk about is two versions of what's called ragged hierarchies. A ragged hierarchy is one that doesn't necessarily have the same number of elements in it for every single one of the hierarchy rows. And an example of that is where we had a region, area, state, and office, but the New York office actually has two branches, the Bronx branch and the Manhattan branch. This would probably be the case typically in some larger cities where you would have some smaller or multiple offices within those cities. So in this case, from the ragged, reason it's called a ragged hierarchy is that Portland does not have a branch, and neither does Buffalo, etc. But we have to deal with this here. So how would you store this as a standard structure? That becomes a lot of nulls, a lot of questions in how things work. Rolling up from a branch level where you don't have a branch makes things a bit more difficult from a reporting standpoint. But we'll talk about how you would implement these within your relationships in a separate video. And just to give you a little bit more about the complexity that we'll talk about in a future video is the ragged hierarchy that is in the middle that you have something missing. So for example, New York might want to be broken up into multiple districts because just as a state is too hard to manage. So we actually have a district level within our New York state offices. So we have a New York City district, we have a North New York district as well. And then our actual offices report upwards. And in this case, you have Portland that does not have districts going to Maine, but within the New York, we do have to deal with districts. How you deal with these, what you do with them, how you design your model, well, again, that is subject for a future video. If you're interested in ragged hierarchies, please stay tuned to this channel, subscribe so you can see when I produce this next video. If you have any other questions about reporting hierarchies and what makes most sense for you, please go ahead and subscribe, drop me some comments, and see what's going on. So just to wrap this up very quickly, we minimize all of this. And that's this. You can create a simple or a complex structure for your hierarchies. I recommend doing it simply unless you have a compelling need to make it more complex. Ragged hierarchies do present a more complex requirement, and we'll discuss those in a separate video. Y'all have a great day. Hope this helped you decide what to do with your hierarchies and how to maintain them within your reporting database and then utilize within your reports.